So today, let's solve the problem from CP31 sheet under the 1000 rated problems. Problem number 50. So let's look at the problem first. So let's read the problem. You have a stripe of checkered paper of length n. Each cell is either white or black. What is the minimum number of cells that must be recolored from white to black in order to have a segment of k consecutive black cells on the stripe? Okay. So in this question, we have been given 2 seconds for each test case. So let's see what the column says. So the column says that we have been given a checkered paper with each cell either black or white. So this can be test case black, black, white, black, white. And we have been given two integers, which are n is equals to like length of the string, which is 5, and k is equals to 3. Here k is given as 3. So we just have to tell the minimum uh, whites to be recolored, the minimum number of whites to be recolored, so that we can find uh, a k elements of black cells, k consecutive elements of black cells. So k is equals to 3, and we have to make three consecutive black cells by removing the minimum number of whites. So here we can see that we can make a three consecutive white uh, segment of the string by removing this white and recoloring it to black. So we can remove this and we can recolor it to black. So we can get three blacks consecutively. This was one way to get three consecutive blacks. For this purpose, we have to tell how many minimum number of whites we have to remove. This is the question. So let us see with an example what we can do here. First, we will see that we have been given only 2 seconds, 2 seconds, so that we can figure out the complexity of the question. So, in 1 second, 10 to the power 8 operations can be done. So, in 2 seconds, 2 into 10 to the power 8 operations can be done. But we can see that here we have been given that the sum of values n does not exist, 2 into 10 to the power 5. And also, k and n both are 2 into 10 to the power 5. So, if we see that, if we consider a O(n) square solution, it would be greater than this. So we can't possibly consider a n square solution because n is already 10 to the power 5. And if we make a square of it, it would be better than this. So this solution won't work. Maybe we can make a solution of On, and also it would work to make a solution of O log n. So let us see what can be the possible approach for this solution. So we can say that if we consider a example, this can be a string of 7 characters n equals to 7, and we have to make maybe a segment of three blacks which are consecutive. So these three blacks can be made by removing this w. These three can be made. These three also can be done. So we just have to know the minimum number of w's to be removed. So we can't check each segment like this. We can't check these segments because if we do that, we have to check for each segment, for each I, we have to include it as the first character. For example, if we iterate from 0, and we consider these three, then these threes. So we have to still go till n minus one, and we have to do n minus one operation still. So, and that too in two loops. Like if for the first loop we have to iterate from 0, 1, 2, and then we have to consider this segment and we have to count number of 12, number of W's. So for this solution, we can use two for loops, but it won't work as it's an n square solution. It's an approximately an n square solution. So if we iterate from I equals to 0 for this string, and then we see for each I, if the next k elements have how many W's. So in this way, we have to make for each I, we have to make a segment. For 0, we made this segment. For 1, we made this segment. For 2, we made this segment. And for each segment, we have to check that how many W's are there and how many W's we have to remove. So this is not the best way to do it. What we can do is that we can make an array simply to store number of W's till ith value. So what does this mean? So the basic idea is to store number of W's till ith position. 5 and 6. So we can say that if we make an array which will store unique positions, ith position of this array will tell that how many W's exist till ith position of this string. So till zeroth position, there is one W. So there will be one here on the zeroth position. Next, we can say till till first position, there is only one W. So there will be one here. Till second position, there is still one. Till third position, we can say that there are two W's. So one will be implemented and here two will be added. Until we find W, we will not increment it. If we find W, we'll make a counter and we'll increment that counter. So what we have to do basically here is we'll first make an array which will give us. So let's see what will be the answer for this case. 2. And here also will be 2. Here will be 3 because there are 3. And here are 3. So 1, 1, 1, 1, 1, 1, 3, 2, and 3. We'll get this array at the end. Now what we will do is we'll check for each ith element that how many W's are there from I to I plus k. So this will be like k elements and we will subtract those. So I'll explain it through this example. Here we can see that till zeroth position there is only one W and till third position there are two W's. So if I want to get W's in this subsegment, which is of k length, what will I do is we already have this array, right? So we are at zeroth position already. So k is 3. If we add 3 to this, we'll get the third position. So till third position, how many W's are there? And till zeroth position, how many W's are there? If we subtract these two values, we can get how many W's are there from after 0, after 0 till 3, which is a segment of k elements. So this is the basic idea. If we get an array like this, we'll iterate from zeroth position and we'll check for each v of or maybe array of I plus k and I array. We'll do this first. I plus k is 0, 1, 2, 3. So 0 plus 3 is 3 is 2 here, and 2 minus 1 will be 1. So we can say that in this segment there are only one W's. There is only one W. If we still consider such cases, like if we go till 1 and then we uh, do I plus k here on the first position, we'll get 4, and this segment will be set because we are subtracting the number of W's till first position from the number of W's till fourth position. So we'll get the number of W's in 2 to 4. So that will also be 1. So we have to get these values and we have to take the minimum of those values. So we'll make another variable. We'll have an answer variable which will store the minimum values, minimum of answer and this difference. So we can get the answer like this. But we can get the answer like this, but there is a one case, one of the cases is remaining here because we check segments from this starting from the first to third and then second to fourth and then third to fifth. But we don't check the first one. Like if I draw this here again, whatever is there. So we didn't check this segment already. So we have to do it. Or if there are like zero, if there is no W here, if there is a B here already, there is already a segment which is of of length 3, and we don't have to minimize the answer, right? So we get 0 here already. We don't have to remove any W. So we can say that the answer in this case is 0. So to check this case, we have to firstly run through all the cases, then we have to take a minimum of the answer we get. So answer we got after running through all the segments in this way. At the end, we can say that uh, another minimum condition will apply that answer. And what are the numbers? What is the first case? Let's see what's the first case. So for getting the W's till this position, till the first K segment position, we can say that we have to get this value, and this is the V of array of K minus 1. So K is 3, and we have to get the number of W's in first 3 elements of the string. We just have to see what is the second position of the array we created. So it is 1. So 1 W is present in first elements. So we can say that it will cover the first case loop, which we left behind. And we can see the submission here. So let us look at the solution. So answer I initiated to int max so that we can minimize it. I took a string as input. Then I created a vector. If s of I is equals to W, then only the counter will plus plus and V of I will be counter. So a new vector will be created here. And only if the ith element of the string is a W, then the counter will be increased and then it will be added to the ith position of the array. So as we created, the first one was W, then second one was D, so it was already 1. Then again we get a W here, so 1, 1, and then we get W, so the counter will be increased here, and the ith element will be 2. So I created a vector like this. This was the vector, and then I run another loop. So while running two loops of mostly and yes, we have to run it till n minus k minus 1 because in the last case, if we do I plus k, it will go out of bounds. So we have to cover that case too. We have to remove k from the last element. So we don't have to check for last three. Last three will be like if we have 5, 6, 7, 8, we don't have to check because we have checked this in the earlier case. If our I goes till here and I plus 3 is done, then it will go to 9 and it will be out of bounds from the indices. And I checked it from I plus k minus v of I. Simply, I did another check for v of k minus 1, which we left behind, and the answer was printed out. So this was the basic output of the solution. Okay, thank you.